Hello, this is simply about networking protocols, and today I'll tell you about BGP best path selection, also known as best route selection or breaking ties. Standard that describes this, RFC 4271. Document that describes Cisco behavior in this procedure is following. Please take into consideration that different Cisco families and different versions can differ a little bit between each other. So this document describes behavior for families and versions mentioned in this document or related documents. In this video, we'll talk a little bit more about routes collection, best path selection per RFC and Cisco-like, and I provide additional mapping of show IP BGP fields to best path selection procedure. As you remember, all the network can be global network, can be presented as set of autonomous systems with interconnections between them. And those devices that are border devices for autonomous systems are usually or always BGP-enabled devices that exchange routing information and building routes, routing tables that in future in internal gateway protocols can be used to build a path from one autonomous system or from device from one autonomous system to device in another autonomous system, and this pass always till the boundary of the local autonomous system. So we have some network and device in the network that needs to send traffic to a device in another network that is placed in another autonomous system. First step is pretty obvious. This device knows the network border router and sends information to it. And this, well, in this particular case, we have two passes, but eventually taking into consideration complexity of the global network, it can be more. Two passes are, for example. So we have one path that looks longer because it through the multiple autonomous system, and second pass that is much shorter to the neighboring autonomous system and then to the network looks perfect. This is a dilemma because it always depends on the configuration, and it could be that in path that includes multiple autonomous system, it actually can be shorter and quicker than paths that utilize only link between two neighboring autonomous systems, but inside the autonomous system from this particular entry, it will be very complex topology that will take much longer for the traffic to pass than utilization through the multiple autonomous systems. But we don't know that. From the network boundary router point of view, it needs to send traffic to the specific network, and from its point of view, it sends traffic to neighboring or autonomous system border device. So this router needs to know which border device to use to send this traffic. Doesn't care and will not know nothing beyond that. So would be obvious to send it to nearest to the border device that is nearest to the autonomous system, but again we can have pretty complex topologies, and eventually anyway we need to know, or in other words, those devices need to know exactly how to reach this network and how to reach this network, right? So they collecting information, and information on BGP device, BGP route can be received internally, EGP, internal gateway protocol, from some internal gateway protocol, from devices that are in the same autonomous system. Or EGP. EGP, those external gateway protocol, and this information is received from peer device that is out of our autonomous system. So those two ways, right? And then those devices, after possible exchange of the information, because inside the autonomous system border devices supposed to be peers as well, needs to build some topology that will be sent to our internal devices within our autonomous system, but still they can remember all the possibilities to reaching necessary network. So let's try on example. We have a green autonomous system from which we will send traffic. Thus, our devices, border devices on the green autonomous system, need to know which path to select. We have two possible passes. One is G1 to B2, green 1 to blue 2, and then to blue 3, or G to green 2 to purple 2, and then through purple red to blue and B3. What and how is used to select? Simple. Well, it looks terrible, I agree. Don't try to remember it, I agree. You just need to remember that both RFC or Cisco or your vendor's documentation will provide necessary information on the stages of path selection, and here I just explaining how it works, just to simplify understanding how it works in your particular case. So RFC splits the procedure of the best path selection to different stages. One is selection of the path, where it is verified that path is correct, next hop is reachable, local preference is measurable, and this is best local preference of all possible, and so on and so forth. And only if we have multiple paths with same local preference, enabled procedure, so-called breaking ties, where we from multiple paths filtering out bad passes or passes with worse value on each stage, selecting one, selecting remaining one. Okay, so after on each stage we expect that passes with worst values will be filtered out, and if remain more than one path, we are going to next stage. Those are eventually stages, so we starting from top to the bottom. On each stage we dropping out paths that have worse values basing on the comparing fields, and if remaining more than one path, we're going to the next stage. Good. Now, I think it is better to start with Cisco and display your mapping with the output, because as you see, RFC doesn't have RFC specific fields. Cisco have Cisco specific fields, so RFC fields work similar in RFC per Cisco. So let's do it like that. If you remember, here is just to remind, if you don't, this is for your information, show IP BGP command that contains information how to read the table and example table, right? So in Cisco, wait. Yes, we have wait here. Wait is not only Cisco specific, but also Cisco proprietary. It means that Cisco and vendors that utilize in Cisco-like CLI will use this wait command. This wait command is device specific and peer specific or next hop specific. So weight is configured per device and not transmitted to any other devices in any means. It cannot be transmitted in frame, it cannot be transmitted somehow else. This is local configuration. And this local configuration provides additional or first filter weight for some specific peer. This is per peer. All paths that have this peer as a next hop will be selected according to weight. If weight for multiple, so all paths that have not the best weight will be sorted out. If we still have multiple paths with same weight that was best, we're going to the next stage, local preference. Local preference per RFC is used to select paths at all. Well, Cisco just not splitting procedure to the stages and also using local preference to select paths at all. Local preference is available in our table. Again, bigger value means better, and we're sorting out all paths that have local preference less than a required best one or the biggest one. If we have multiple paths with same local preference, we're going to the next stage, that is locally originated. Locally originated can be seen in next hop table, and this is related to exact one address 0000. Locally originated, it means that administrator told to the BGP router that this BGP router operates with some specific network, and usually, mostly recommended that those are internal networks. So router G2, for example, operates and advertises outside itself as a next hop to the G3 network to all peers. Then this is locally originated network, and this is so very important. Here you need to remember, mostly, usually, this will be internal network to this specific BGP device. Only 0. No comparison besides 0. Either 0000 or not. If locally originated not 0000 or multiple 0000, then number of autonomous system in autonomous path. The less amount of autonomous systems in the path, the better. How it looks? It looks like that. We have a path column, and here will be listed autonomous systems that our traffic need to pass on its way to the destination. In particular example, we have two possible passes. One is just blue and we're on the destination. A second is through purple, red, blue, so on. So will be selected that one on this particular stage. Then, if we have still have multiple passes with same amount of autonomous system on those passes, smallest amount, we're checking them with the origin. Origin codes, you probably saw them. Those are those value at the end of the pass. How it works? EGP, well, those paths are added to the RIP or routing table, BGP routing table, not filtered. internally, externally, or in some other way. Incomplete, it doesn't mean that those paths are incomplete. It means some another way of adding those paths, those routes into the RIP. The thing is that mostly you won't see E, because EGP here is actually EGP. It means external gateway protocol, like actual external gateway protocol. It is a protocol that named like that. It operating, or at least were operating for a long time. Now it's mostly replaced by external BGP. So for most you will see either I or question mark I better. Then multi-exit disk. This is specific value that is calculated according to the formula. Formula is provided in the RFC. Definitely it will be maybe provided in your documentation for your vendor, like for Cisco or any other vendor, but for RFC it will be available anyways. No need to try to remember it. If we still have some amount of paths that have all of that equal, we're trying to figure out, was it eBGP or iBGP. As we already mentioned, we can receive packet externally or externally, and for some configurations, so there is potentially a loop, and we can receive information, for example, on this BGP router border device. We can receive information that externally from eBGP from neighboring autonomous system, or we can receive information about reachability to the B3 network from our peer device inside autonomous system. This will be iBGP, eBGP, iBGP, eBGP, iBGP, eBGP, external, internal, external, internal. We prefer external. Why? Because we assume that internal is a loop. If we have some external network that is provided to us by external device, it is better than external network provided to us by internal device. So we have to use our internal resources to process traffic. Why? That another organization spend those resources. Everything is correct. Unfortunately, there is no direct mapping to this field. Then, best path. Best path, again, this is for specific mode of BGP routers operation within the Cisco, and it called best path. So once we have a best path, single, then we're done. We have it. If we don't have best path, then we go into the next stage and comparing. Path H, how it looks like. Again, no direct match to the field. So path H, we can receive some specific path. If you remember, or how you remember from BGP overview, connection between peer devices is stable, and they operating as BGP devices until there is connection available. And once this connection established, they exchange some routes, routing information, and build the necessary paths. So we can expect that after establishing connection and receiving some route, if we're receiving this route later from different destination or somehow else, this route just passed more hops. It is longer. This is why we received it later. Then, metric. Metric is something that is calculated being transmitted in frames, and it has direct mapping to the fields of show IP BGP. The bigger, the better. the bigger number means better. And we're selecting path with bigger matrix. If every previous stages still display our path as equal. Then BGP ID speaker. BGP ID speaker has no information in this table directly. So this is router ID speaker, and it being connected, it being compared internally basing on the speaker ID that will transmit this information further. So it is not displayed on this table. Cluster length for specific mode of operations of BGP devices that running with Cisco, and peer addresses. You can find them here. Partially. Why partially? Again, how you remember? Router ID, speaker ID, BGP ID, whatever. This is the highest IP address that identifies some specific BGP border device. But this device can contain multiple networks, and thus it will have multiple next hops to it, and only one of these next hop will be peer address. This is why peer address can be present in next hops, but not necessary next hop. Okay, this is why only partially visibility. So how you see, it looks pretty scary, but in reality it's very simple and straightforward. And same, we will review all this huge, big, giant protocol, split it into the sections that are straightforward and very simple, and try to understand it. Thank you. Have a great day.